Okay guys, section 7.4 and 7.7. There's our objectives and standards today. I'm going to go quickly because if you need to, you can go back and hit pause or rewind. So when we have this square root of 2 times this binomial, all you're going to simply do is you're just going to distribute it through. So now you have 6 times the square root of 2 plus the square root of 2 times the square root of 10 would give me the square root of 20. And then we know how to break down the square root of 20. That's 4 times 5. So then I can rewrite that as 6 square root of 2 plus 2 square root of 5. And since those are not like radicals, that's as far as I can go with it. Okay, next problem. So when I have this binomial times the binomial, just FOIL through. So square root of 3 times square root of 2 is the square root of 6. And the outer would be 7 square root of 3 plus 7 square root of 3. The inner would be minus square root of 20. And the last would be minus 7 square root of 5. Now don't think you're done because the square root of 20 will simplify. We just did it. So now I have square root of 6 plus 7 square root of 3 minus 2 square root of 5 minus 7 square root of 5. And then I can combine these radicals. So I have square root of 6 plus 7 square root of 3 minus 9 square root of 5. And that's as far as I can take it. Okay, third example. I'll just talk you through it. When you multiply this one through, notice how we are going to take the square root of 5y times square root of 5y. So when you have the square root of the same thing, you should recognize that that's technically the square root of 25y squared, but that simplifies into 5y. So if I have the square root of something times the square root of the same something, it just becomes that something without the square root. So I have 5y. And then you should notice your outer and your inner terms cancel, and minus 4. Okay, so in that last example we saw the binomials, number 3, are called conjugates of one another. They differ by only the sign of the second term. So I just want to make you aware of that. In this example, we remember this is actually the square root of 3 minus 7 times the square root of 3 minus 7. It's your choice of writing it out or not. You just got to get it right. So when you take the first times the first, the square root of 3 times the square root of 3 is 3. Now your outer term's negative 7 square root of 3, your inner term's negative 7 square root of 3, so that becomes minus 14 square root of 3 plus 49, and 3 plus 49 is 52 minus 14 square root of 3. Next example. Again, this is a binomial where it's the square root of x plus 1 plus 2 times the square root of x plus 1 plus 2. Let's try it without writing the binomial twice. So this right here we're going to square, so that becomes x plus 1 without the radical. And then 2 of them plus another 2 of them would be plus 4 square root of x plus 1. And then 2 squared is plus 4. And then I can simplify and take that 1 plus the 4, so I'm going to write it as x. 1 plus 4 is 5 plus 4 square root of x plus 1. And this is your simplified answer. I apologize for my penmanship. Okay. So here I have a binomial times a trinomial. Take this binomial, distribute it through. So the cube root of 2x times the cube root of 4x squared. I'm not even going to waste my time writing the cube root of 8x cubed. I'm going to go straight to 2x. The cube, excuse me guys, we're real, well, excuse me real quick. Yes ma'am. I do. Got it, thank you. William. You interrupted my video. You're going to take your vaccine record to the nurse's office. Thanks for messing my day up. All right. So continue. The cube root of 2x times the cube root of 2x would be the positive cube root of 4x squared, and the cube root of 2x times 9 is 9 cube root of 2x. Now I got to distribute this negative 3 through, so that would give me negative 3 cube root of 4x squared. I'm going to line it up under this one. Negative 3 cube root of 4x squared. Negative 3 times cube root of 2x, so I'm going to line it up here. Negative 3 cube root of 2x, and then negative 3 times 9 would be negative 27. So when I combine the like radicals, I'm going to finish with what? 2x, and then one of them minus 3 of them would be minus 2 cube root of 4x squared. 9, I think that, yeah, 9 minus 3 would be plus 6 cube root of 2x, and then minus 27. And I don't think I can get anything to simplify any further, so that is my answer right there. Alright, so now we're going to talk about rationalizing the denominator. These should go pretty quickly here. So if I have the 2 over square root of 5, and I've already hinted at it, that you can't have a simplified rational expression with a radical in the denominator. So you need to rationalize it. In this example, all you have to do is multiply both sides by the square root of 5. Now I want you guys to think about it. I'm not changing the essence of this problem at all. Square root of 5 over square root of 5 is 1. So anything times 1 keeps it exactly the same. So now all I got to do is I multiply through. 2 times square root of 5 gives me 2 square root of 5. And square root of 5 times square root of 5 is 5. And now I've simplified that without having a radical in the denominator. So sometimes before you rationalize, look to see if you can simplify it. First of all, we know the square root of 16 is 4, so 4 times 2 is 8. Over, isn't the square root of 9 3? And then the square root of x is left over. So to rationalize this denominator, you multiply both top and bottom by the square root of x, which gives me 8 square root of x over 3x. Because remember, square root of x times square root of x gives me x. So now in this case, I have the cube root of 1, which we know is 1, over, I can't simplify the cube root of 2. Now I have to rationalize the denominator. Multiplying by the cube root of 2 would not be enough, because the cube root of 2 times cube root of 2 would still be the cube root of 4. What you need to multiply is the cube root of 4. And think about it. What is the cube root of 2 times the cube root of 4? It's the cube root of 8, which gives me 2, over, and then in the numerator would be the cube root of 4. Okay, so in this example, simplify if you can. In this case, I can't because I have the 4th root of 8. So all I need to multiply this radical expression by to get the radical to go away in our denominator would be the 4th root, maybe if I can write it, the 4th root of 2, because the 4th root of 2 times the 4th root of 8 is the 4th root of 16, which is 2. And in our numerator we'd have still left over the 4th root of 2. I apologize for the penmanship, it's not letting me make it a little cleaner. There's a delay in my communication with my iPad and my computer. Okay, so again we look at this example. Excuse me, I don't know what I did there. There we go. So in this example, I have the fourth root of x over the fourth root of 81 y to the fifth. The only thing I can simplify is the fourth root of y to the fifth in the denominator. So I'm going to take this fourth root of x and I'm going to leave it. So I have the fourth root of x over the fourth root of, wait a minute, I can do more than that. Here, let's erase that. I can, this is really ugly, apologize. So let's erase it all. Okay, the fourth root of x stays. But isn't the fourth root of 81 3? And then the fourth root of y to the fifth would be y with a fourth root of y left over. Now, to rationalize the denominator, because you can't have the fourth root of y, we're going to multiply both top and bottom by the fourth root of y cubed. That's our rationalization. And that will give me, in my denominator, 3. I have this y out in front with the fourth root of y times the fourth root of y cubed becomes y, so it becomes y squared. And then in the numerator would be the fourth root of x y cubed. So now, this isn't just a simple monomial expression in the denominator. I have the square root of 5 plus 2. This is when we multiply by the conjugate. And I mentioned it to you, it's the exact same thing except opposite sign. So we're going to multiply by the conjugate, which is the square root of 5 minus 2 instead of plus 2. And you got to do the exact same thing to the numerator. So in my denominator, I'll do that first. I have the square root of 5 plus 2 times the square root of 5 minus 2, just FOIL. Square root of 5 times square root of 5 is 5. Your outer and inner will cancel, and 2 times negative 2 is negative 4. We'll simplify that to 1 here in a second. In our numerator, I have 5 times square root of 5 minus 5 times 2 is 10. So then I can take that through one more step and go 5 minus 4 is 1. So my final answer is 5 square root of 5 minus 10. So in this example, we're still going to multiply by the conjugate, but this time it's the square root of 3 plus the square root of 5. And that's what I put in the numerator also. So we can go ahead and do the numerator first. Square root of 2 times square root of 3 would be the square root of 6. Outer would be square root of 10. Inner would be plus 5 square root of 3. And last would be 5 square root of 5. And I can already tell you right now, none of that's simplifying. Over, and let's see here, our square root of 3 times square root of 3 would be 3. Our outer would be square root of 15. Our inner would be negative square root of 15. And our last would be minus 5. So we could probably do that in our head, where we could just go, okay, square root of 3 times square root of 3, 3 minus 5, which would give me, what, negative 2? And I only simplify from here if everything has a negative 2 or a 2, and it does not. So that's my simplified answer. So we'll skip that one because that's just like the example we did. And then we have a complex number system, which we know an imaginary number we talked about a little bit, but we'll go in more detail. I squared equals negative 1, so imaginary number is the only kind of number when you square it, it's still negative. And then we know also that I is equal to the square root of 1. So when I have the square root of negative 25, we know that becomes 5I, because technically it's this. It's the square root of 25 times the square root of negative 1. We know the square root of 25 is 5, and we know the square root of negative 1 is I. So that's why it's 5I. So this would, the square root of negative 6 would be, I can't break down square root of 6, but I know the square root of that negative 1 is I. So the answer is I square root of 6. So the square root of negative 27, we know 27 is 9 and 3, so we go the square root of 9 is 3i square root of 3. So now, product rule for radicals does not necessarily hold true. You cannot rewrite this as negative 4 times negative 9 and make it positive 36. That's not true. You have to do each of these separately. So we know the square root of negative 4 is 2i, and we know the square root of negative 9 is 3i, and we know 2i times 3i is 6i squared, and haven't we already said that I squared is negative 1? So 6 times negative 1, the final answer would be negative 6. Okay. So again, on this one, you need to do each of them separately. So the square root of negative 5 is I square root of 5, and the square root of negative 6 is I square root of 6. And then we multiply together. I times I is I squared. The square root of 5 times square root of 6 is square root of 30. And then I squared is negative 1, so it would be negative square root of 30. So again, do this one separately. We know the square root of 125 is 25 times 5, so 5 square root of 5. We know the square root of negative 5 is I square root of 5, so 5 times I is 5i. Square root of 5 times square root of 5 is 5, and 5i times 5 is 25i. Okay, square root of negative 27 over the square root of 3. Let's simplify that square root of negative 27 first. That is what? 3i over square root of 3, or times square root of 3, and then the denominator square root of 3. So now I can cancel these, and my answer would just be 3i. So a complex number is a number that can be written in the form a plus bi, where a and b are real numbers, but the bi becomes an imaginary number. So when I have 2 plus 3i plus negative 3 plus 5i, it's that easy. All you do is you combine your like terms. So 2 plus negative 3 would be negative 1, and then 3i plus 5i would be 8i. So here I have a minus. Make sure you take that minus and distribute it through, and then combine the proper like terms. Negative 7 plus 2 is negative 5. 5i plus 8i would be 13i. So here all we're going to do is combine like terms again, and notice that when I go negative 5i plus that 5i, it cancels, so my answer would just be negative 3. And then this one, negative 5i times 4i would be negative 20i squared. But hold on, isn't I squared negative 1? So it's technically negative 20 times negative 1. Don't you love that penmanship? And negative 20 times negative 1 is positive 20. So here we're going to distribute through. So 4i times negative 2 would be negative 8i. And 4i times 6i would be positive 24i squared. But you already know that I squared is negative 1, so your answer technically is negative 24 minus 8i. Notice how I wrote the real term before the imaginary term. I'd like for you guys to do that. And here we're going to FOIL a binomial times a binomial. So 8 times 2 is 16. Our outer is negative 18i. Our inner is 24. So 24 minus 18 would be positive 6i. And then negative 27i squared. But we know that I squared is right here is negative 1. So negative 1 times negative 27 is positive 27. So 27 plus 16 would give me what? 43 plus 6i, and that be your answer. And this, we've done these where you just take 4 minus 3i squared, you do it twice. We just did an example like this. Let's do this one real quick here. So 7 plus 3i times 7 minus 3i, 7 times 7 is 49. The outer and inner cancel, and then I'm going to get minus 9i squared, but I squared is negative 9, so it's technically 49 plus 9, which gives me 58. And then again, just like with simplifying radicals, you can't have an imaginary number in the denominator, so just multiply by the conjugate. In this case, it would be 1 plus I. So we're going to multiply both top and bottom by 1 plus I. So when I do that, my numerator becomes 2, and then I'm going to take 2 times I plus I, which gives me plus 3i, and then I times I is plus I squared. We'll simplify that here in a second. In our denominator, we get 1 minus I times 1 plus I, so 1 times 1 is 1. The outer and inner cancel, and I get minus I squared, which is really plus 1, so 1 plus 1 is 2. And then I'm going to simplify it one step further. I'm going to take this 2, and this is a minus 1, so I get 1 plus 3i all over 2. Same thing for this one, you would multiply by the conjugate, which would be 3 minus I. And then in this one, all you would have to do is multiply by I. So when I do that, I multiply by I get 7i in the numerator. In the denominator, I would get negative 3 because I times I is like negative 1 times 3, so 7i over negative 3. Last thing we're going to talk about, we know I squared is negative 1. So what would I cubed be? Well, isn't I cubed I squared times I? So isn't that I, or excuse me, I squared is negative 1, so negative 1 times I, which would be negative I. And isn't I to the 4th I squared times I squared? And isn't that negative 1 times negative 1? And negative 1 times negative 1 is 1. So I to the 4th is 1. So how do I simplify I to the 9th? What you want to do is you want to try to divide out how many 4s. Since we know I to the 9th has 2 4s in it, if you will, it's I to the, it's I to the 4th squared, that's 8, times I. And we know I to the 4th we just found was 1. 1 squared is 1. 1 times I gives me I. So all you're going to do is you're going to basically divide out by 4, and whatever your remainder is what you're working with. So we know I to the 16th is I to the 4th raised to the 4th. Isn't I to the 4th 1, and isn't 1 to the 4th 1? So I to the negative 24th. Well, first of all, you need to rewrite it with positive exponents. So this is the same thing as 1 over I to the 24th. And then I know that this equals 1 over I to the 4th raised to the 6th. I to the 4th is 1, 1 to the 6th is 1, 1 over 1 gives me 1. And there's our homework assignment for today. I appreciate you guys doing a good job for the sub in my absence. Thank you.